Tepid Coder here. Today I want to talk about threading. And in order to do that, I want to show a practical example of why you might want threading. And I think I'm going to do it using a UI application. And this is going to be dumb. I'm going to use Windows 32 API. If you aren't interested in that, I don't blame you. No one's really used that in a long time for applications in any serious capacity. But I think this will be good because I can do some task, and I can show the UI kind of freezing if it's busy doing something. And no one wants a window to say it's not responding and then crash if you click on it a couple times while it's busy. So, let's show that. I'll make a new project. Okay. It's being slow today. Why is it being so slow? Okay, empty project. Let's call this UI application. Actually, I don't want to call it that. I want it to have to do with threads. So I'm going to call it, I don't know, thread stuff. Good enough. Okay, I'm going to add a source file here. Source file is going to be called thread stuff. I usually like to name my main file after the project itself, if I'm working with nitty. Let me think here. I need windows.h. When main is going to be, wait, when API, and I haven't done this in a long time. H instance, H inst, H previous instance, and then what was it? It was pstr, scc line, and then something like that. I'm pretty sure that's the right thing. Right signature. Let's see here. Let's drop down the next line. Alright. Let's do handles a window. H window. It's funny, like, I don't really use camel case like that anymore, but I used to have this whole thing memorized where I didn't need to type ahead back when I was in my teens. I definitely need to type ahead now for when class ex wc dot something. What was it? It should give me some type ahead. Come on, baby. Ah, it's wc. What is it? In class extra or something like that equals yeah, what is it? Why is it not finding this? Oh, A. Is that why? For my project settings right now. Let's go over to properties. What's it building for? Is it using Unicode? Or is it not using Unicode? Unicode, yeah it is. Okay. So what I actually want is W. It should give me some type ahead here. What is going on? Expecting a semicolon. Why is it expecting a semicolon? I'm just gonna go to the definition then. Fine. Grab all of this. It's not gonna give me my type ahead. I'll do it myself. Look at that. Okay, class name. I actually do need to define that. Okay. This is going to be null. I'm not going to have a menu. Class name. I'll just call this thread stuff. Oops. Window class. In fact, main window class. And this needs to be L in front of that because it's a wchar. It's const wchar t. Anyway, because the project's Unicode. Background, I'm just going to say hbrush. I have to cast this. It's going to be get stock object. I'll do black brush. Okay, equals, what is it? H cursor. It's load cursor W. Oops, it's going to be null. Or I could do H inst here, and I could say, what is that? IDC arrow? Yeah, okay. Okay, and this is, what is it? Load icon W. Which inst, I'm going to say IDI application. Okay, and this is going to be which inst. Okay, that's already zeroed. I don't care about that. Don't care about that either. I mean, technically I could use these for doing this in a more class-based approach. Maybe I'll show that later. I don't know. It's a lot of extra setup, so I'm not sure if I'll do it or not. Okay, winproc. This is where things get interesting. Equals, let's say, thread stuff main window procedure. Yeah. And that has this kind of signature. It's like L result callback, and it's got a window handle. It's got unsigned int message. Man, I'll just leave it how I'm used to typing it, because it's gonna confuse me if I don't. Even though I haven't done this in so long, it's like muscle memory now. Param, param, return def window proc w. And I could just do this, it's a macro. It automatically default to w because it's Unicode, but I like being explicit. Okay, for this window, with this message, with this w parameter, and this L parameter. Okay. So, what am I going to do here? Let me think. On wm create. Hey, damn type ahead. Okay, so, I'm going to do switch message. Okay. And then I want to say create return 0. Okay. Okay, SWM destroy. That's when you free your resources. Okay, and then I'm gonna do close. After they hit the X button, we're gonna say let's say destroy window. It's gonna be this window that we're destroying. Destroy, we're going to do post quit message. This is going to end our message loop. Okay, and here I need to initialize stuff. Okay, so what do we have here? CB size is going to be size of wind. Wind class EX. I could also just do WC because it's of that type, but I don't know. I like to be explicit in the size of, just show exactly what it is that I'm working with. Okay, let's copy that. Okay. Okay. Okay, equals wc.h icon. I can just copy it from the other one. I'm assigning it here. It's just going to be the same value. Put them together. Okay, anything else I need to think about? So I have the win class set up. Style needs to be CSH redraw or CSV redraw. So if you resize it this way or resize it that way, vertically or horizontally, it's going to repaint the window. Okay, and we're going to do register class EXW, and it's going to be WC, our window class. I'm going to say, let's see, HW equals, actually I call it H window. Create window EXW, and it's EX style. I could do like WSEX topmost. Yeah, I wanted to. That way it's always on top, just for fun. Okay, class name, it's going to be this. Okay, window name, let's call it thread test window. Okay, style, it's going to be VS overlapped window or WS visible. Overlap window has like a minimize button, maximize button, close button. It can be resized. It's got a thick border, you know. And visible just means you can actually see it. You could make a window you can't see by default. So let's do 0, 0, 400, 400 for the screen coordinates. It's going to start top left, 0, 0, and then it's going to be 400 wide by 400 tall. Okay. And then what we're going to do is we're going to say the parent. It has no parent. It is the base window. Menu, it doesn't have one. Okay, instance is instanced. And we're going to say, this is extra arguments you can add, but we're not going to use that right now. So I'm just going to say 0. Okay, so we created the window. Now we need to do while get message w. It's going to be reference to the message. We're going to get it for all windows, so I'm just going to put a null pointer here. And then 0, 0, we want all the messages that we can capture. Okay, then we're going to say translate message. Oops. Not my sausage. Okay, and message. Is there an A here? Or W? No, I don't think so. Dispatch message. It is a W for this, though. Okay. Cool. And then, customarily, you return message.wparam. Okay. So at this point, I should have a window I can move around and stuff, and I can close it and whatnot. Okay, do that. Pass by reference. Yeah, so I'll do one quick thing first. I'm gonna say something like static HC. I'm gonna say static hbrush. No, I'm not gonna even do that. Yeah, I'm not gonna do that. I think here I could do HWM print. We're gonna say HDC equals again paint. We're gonna paint for this window. We're gonna paint to paint struct we need. That's right. That's like paint struct. Yes, let's say cool. And then we're gonna say end paint when we're done. It's gonna be this window and paint struct. And here we can do stuff like text out W. We're gonna say HC. We're gonna say is it XY and then string length? Yeah, XY string length. Okay. Let's do 0 0. It's the top left of the window, client area. And the string is going to be something like texting, which is 7 characters. So I'm going to say 7 here. Okay. I think I'm going to try and run that now. Do I still got the mojo? Nope. Don't got the mojo. Uh-huh. Really? It might be high. That should be fine. I could just static cast into int. Okay, what is the annotations? Does it not want to be a Windows 32 application? I bet that's the problem. I think it's subsystem Windows what I need to put in here. Where's all options? Sub. Okay, it's gonna be linker then, which makes sense because like mconsole on Windows, I think. So subsystem is console right now. That's the problem. I'm gonna use for all configurations. Yep, good. Okay, Windows. Cool. Let's try and build that again. And now it's happy. Let's run it. And look at that. Programming like it's 1995. Got a little Windows API window here. Isn't that neat? I can maximize it, move it around, close it, minimize, whatever. Okay, so let's actually add some stuff to it. Let's see if I can remember anything. Static, window, sh, button, pointer. I'm just going to default it to that. Remember, for static variables, if you have something static in a function, this whole thing here, this callback function, is the function I'm talking about. The first time this function runs, it's going to initialize this to whatever you say. I'm initializing it to a null pointer. Every other time it runs, it's like going to keep whatever value it had previously and not assign it again. Now, if this wasn't static, it would just assign it to null pointer every time. So I don't want that. So what I need to do here, let's see if I can remember how to do this. Button equals create window W. I'm just going to say, and there should be a window class I can already use that handles this for me. So the class name should just be button, I think. Window name, click me, and then okay. Style is going to be what, WS? No, is it BS push button? Push button. It is BS push button. Ha! Do I need WS visible for this? It definitely needs to be a WS child window. Okay. Let's back over here. Okay, so we have XY. Let's put it on all the way in the left wall, let's say, and we'll say the Y position is going to be at 20, because that's going to be about the size of the default text. And width and height. I don't know what the width needs to be for this. I always wish this would calculate that for you. I'm going to say 150 pixels by 20. The parent is going to be this window, and then it doesn't have a menu. And the instance, I'm just going to say ghInst. I want to make a global instance that I can use. Okay, so right here. ghInst equals hinst. Okay, I'm going to make this global over here. Yep. Got it. ghInst, I'll do it like that. That's fine. By default, it's just 0, I guess. I need to do that. Let's do that. Okay, there we go. So, ghInst. I'm actually setting that here. Okay, and then over here I need the instance, so I'm going to put it right here. XW, and I guess I'm just going to put a 0 for the X style. Yeah. So, where am I now? So, menu, instance, alright, extra parameter is just going to be 0. Okay, and then let me think here. I'll label these X, Y, width, height. Oops, height. Kind of was still height there. Okay, we have case. What is it? WM command, I think. I think it's which lparam. I think the lparam holds the window handle usually, and I didn't want to do it that way. What if I just do this? If lparam, let's convert it into a window handle, equals, I'm going to say h, what is it, button, I called it, and let's do this, message box w, it's a wide character version, text is going to be, I don't know, you pressed your button, and then the title is like, I don't know, note you push the button. Maybe icon, exclamation, which is usually used for like errors or warning or something, but whatever. Let's see if that works. I probably messed up a WM command there, but maybe it worked. So I have a button, that's good. So click it. Hey, it worked. I did it. I remembered how. Wow. Wow. Man, okay, so let's do something stupid now. Whenever I click this, I'm going to, instead of popping up message box, I'm going to say sleep, Windows specific function here, and we're going to sleep for 1 second, it's 1,000 milliseconds. I could also do something like standard, what is it? No, standard this thread sleep for, and like something like, what is it, chrono milliseconds, and then like 1,000, that would work too. Like, I'll do that. Let's see. Include chrono, include thread. I'm also going to include new text. I'll need that later. Okay. What else here? So that should sleep when I press the button. Let's try that. I'll make it sleep, and then I'm going to try to move the window around, and you'll see that I won't be able to. So, click. Now I can't move it. I didn't like that. Can't move it. Can't move it. There it goes. Now it moves. I'll try and resize it. I can't even get the resize button. So see, it freezes up the thread when you're doing something like that. It can't do my callback function because the callback function is still happening. It's all the same thread. So, what I can do, imagine the sleep is actually some operation we're performing. So like maybe we're loading a file and we're encrypting it or something and it's like a giant file, or maybe we're doing some kind of compression that takes a while. So if this were a compression application that lets me select files and compress them or whatever, maybe drop a whole folder and compress it all at once, then I would be able to click the button, have it do that operation, but it would freeze the UI while the compression's happening. So what I could do instead is I could say start a thread. So standard thread, and we're going to pass it a function. I'm going to use a lambda for it. It doesn't have to be a lambda, but that's what I'm going to do. It's going to return void. Okay. 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 Good. Here we go. Okay, let's give it a name. Call it th. I don't know, th for thread. If I really wanted to, I could also just do this. Thread dot detach, right? So create the thread and then don't wait for the thread. There's also like standard JThread, which will just, it'll wait on the thread to finish when it goes out of scope. That's interesting. I would think that that would, maybe it needs a newer version of C++ for that. I don't want to use that anyway though. I do want it to be detached. Anyway, so I'm going to create a thread, which should start running immediately as soon as I do this. And what's going to happen is, it's going to go out of scope right here, which is bad. If it's doing anything, it's going to go out of scope before maybe it finishes. And if it's like referencing something, like say I have like a reference here to everything in this scope, from here to here, right? And I have some kind of item, let's call it like int I, and I try to use I here, you know, for something. It's actually going to go out of scope immediately because the thread's immediately going to start running, and it's going to hit this. And reference being out of scope. So that's really bad. Of course, I could copy it like this. Or I could also pass it as an argument to the thread. It takes another parameter like this if you wanted to. It's optional. You could pass something here. And if I wanted to pass a pointer to something, I could do standard reference wrapper of type T, say it's an int here. This would actually mean that I'm passing an int pointer, right? Or more like a int and like that. Pass the I in there. Anyway, there's a lot of options there. In this case, I just want to make a thread. I'm going to call it th. Then I'm going to detach it. And what you're going to see is, even though it's sleeping, it's not going to freeze the UI. Okay. So, let's click it. Nothing's happened. Still do it. Yep. Just fine. I'm going to click it a bunch of times. There's a bunch of threads running. You can see them all stopping over here. Watch, I'll start a bunch of them. There they all go. So that's really nice. You can have a responsive UI with that. And there's other cases where you can use this, where, like, say you're running a server. So if this were a server application, I might have something like, I don't know, while get new client, let's say. So you're waiting for someone to connect to your server, right? And you might say, okay, accept client. Right. I'll do that, accept client. Of course, I'd be actually returning this into something, right? Well, something equals this, well, you know, maybe some socket, right? And get new client would probably like listen, and then it would accept, and then return a socket. If you turn an invalid socket, maybe we quit, whatever. Really, I'd probably say, well, not, you know, we quit. Maybe there's some operation we want to quit. You issue some kind of shutdown command or something, or signal will hang up, whatever it's going to be. So you say socket, get new client, and you're going to say something like, you know, standard thread. And you make some kind of a thread that handles the client, right? Detach. And that's pretty cool because you can immediately go back to the top of the loop, and if we're not done handling clients, we can just immediately try and get a new client and then immediately serve that client as well. So that's really cool. Otherwise, you'd have to be grabbing one client, serving the client, whatever this is doing, you know, and then you wait for the next client and then grab it and serve it. This lets you handle many clients all at once. So Thread's really useful for that. Anyway, I do want to show an example where I need to use a mutex. So here's what I'm going to do. Future type of decoder here. I'm kind of punching in and going to give a simpler example than I gave earlier. Well, you didn't see the earlier example. You saw the UI freezing thing. So I think what I want to do here is do thread example. I'm going to edit. Okay, I'm going to include thread. I'm going to include mutex. I'm going to need. And I'm going to include IO stream, and then I'm going to include vector. I think that's probably all I'm going to need. So what I'm going to do here is I'm going to have a bunch of threads working together to calculate some sum. So it's going to be a really large number. Let's call it UI64 number equals 0 to start with, and we're going to say we have a standard vector of standard threads. Right, standard threads. So v threads, I'll call it. Okay, and what we're going to do here is we're going to start a bunch of these threads and stick them inside the vector so we can join them later. So I'm going to say STI equals 0, STI. Actually, I'm going to call it thread index. Thread index, that sounds better. Thread index less than 10, let's say. ST thread index plus plus. Okay, that's looking pretty good. Yeah, I can't wait. In 2 days, I'll have that new keyboard. Although from your perspective, I don't know when that's going to be. It's the 8th today for me, for reference. It should come on the 10th. Okay, anyway, so v threads dot in place back. Now, what I could do is I could just stick the lambda right here, like this. But that's kind of hard to read because everything's getting pushed really far over at this point, right? We got a for loop here, we got in place back, and then pushing further for the lambda, and then we're pushing further for a for loop I'm going to do inside of here. So instead of doing that, I'm actually going to show you a different way to define a lambda. What we're going to do here is do auto and say function thread callback, or thread function, you know, thread function. So equals, you just do the same thing, right? Semicolon. That's kind of cool, right? So now it's not pushed way over, and I can see what the thread's doing really easily. What am I copying? I'm going to do a reference to UI64 number. So all the threads are going to be working with this right here. So I'm capturing that. And what I want to do is for, actually I'm going to say STI again. STI equals 0, STI less than, what do I say? How about 100,000 each? Okay. STI plus plus, and then let's do something like UI64 number plus equals 2. So now, this isn't going to work, FYI, and I'll fix it and make it work in a second. What I'm going to have each of these threads do is add 2 to the value, whatever it currently is, 100,000 times. So each thread's going to add 200,000. I'm going to spawn 10 of these threads. So I have 200,000 times 10. So, big number. what would that be? It'd be 2 million, right? So I'm going to pass this function to a thread. Function. And if I had extra arguments, I could also pass those, right? But I'm not going to. I only just need to pass this thread I want to run with no extra arguments being passed into here, because I'm already capturing this scope. Now, if I wanted to, I could do something like standard reference wrapper, and I could do uint64t, and I could wrap uint64 number. I could define that right in here like this, uint64t, and then ampersand for number. Man, I cannot type right now. Well, when can I ever type anymore, to be fair? It's a persistent problem. Anyway, I'll show it both ways. But first I just want to show it not working and giving me a bad value. So let's do standard cout. I'm going to do uint64 number. I'm going to do standard line. And I don't trust that cout's going to format this properly, so I'm actually going to cast it into an unsigned int, which I know is fine to hold a 64-bit unsigned integer because I'm compiling a 64-bit application, which is right here, UI64, unsigned 64-bit integer. So, yeah. So we're going to run this thread function 10 times. It's going to create 10 threads. Each one's going to add 200,000, so we should get 2 million. And before I run this, I'm going to say for each of the threads that I made, auto reference th with thread. So the current thread I'm pulling out of vthread vector. Threads, okay. So I'm iterating through all the threads in this vector of standard threads, right? Standard vector, standard thread. So for each of those elements, those standard thread elements, I'm going to say th.join. So I'm joining the thread. We're going to wait until that thread finishes. And then we'll go to the next iteration, wait till that thread finishes. They're probably all going to finish around the same time, because they're all doing the same exact thing. Anyway, let's see what happens here. I'm going to do G++. I'm going to do standard equals C++20. Don't really need that right now, but I will. I'm going to need to link in a library called pthread, and then I'm going to have to compile thread example.cpp, and the output's going to be thread example. What do we get? Okay, fm thread function. Nice, instead of fn. So right here, we're going to fix that. Okay, clear, try that again. Good example. And it did not give me 2 million. You can see it's a pretty large number. It's around 1 million. So what's happening here is you're going to have multiple threads fighting for the same address right here. They're all grabbing that variable address by reference, and they're saying, hey, right now the number's 0. The other one's like, oh, the number's 0. You see like 2 of them at once, let's pretend, all saying, you know, all 2 of them saying this number is 0, and they're like, okay, I should add 2 to it and then assign that to this address. So we're going to update it to 2. The problem is both of them did that. One should have been saying this is 0, let's make it 2. The other one should be saying, okay, now it's 2, let's make it 4. We want them all to take turns and not fight for that number. So what we're going to do here is we're going to say standard mutex. Standard mutex mtx. What's going to happen is, if in a thread you type mutex lock, you lock a standard mutex. By the way, I need to pass that by reference. So they're sharing the same mutex. It's going to try and lock this mutex, but if it's already locked by another thread, it's just going to wait until it can lock it. So that thread has to wait until another thread touches this value. Okay, so we're going to lock it, we're going to update the value, then we're going to say mtx unlock. And there's a different way to do this I'm going to show. So if you got your dander up, hold on a second. I just want to show that 6 is the problem real quick, and then we'll move on. Okay, so every time I run it, it's always going to work, because every thread has to wait. And here it is if I pass extra arguments to my thread function. So, do that. I'm only going to capture the mutex in this case. I could also pass this by reference, but I'm not. I'm just going to pass the reference to the number as an argument to this thread function. And down here, you can either use standard ref, which automatically deduces the type. I'll show that. Still works. Or you could use standard reference wrapper, and you could specify the type that you want it to be. In this case, it's going to be a uint64t reference, like that. So, and there it is. So you can see that working. And normally this is not how you want to handle things. It'd be better if I was calculating a bunch of different values to maybe put the calculation I'm sticking into different segments, let's say, of an array through which I want to iterate for each thread. That way they can all work in parallel. Right now I'm basically forcing it into basically the same thing to be doing in a single thread, which is bad. Anyway, instead of doing this, there's a modern way of doing it, which is standard lock guard. Let's call it LG, and we're going to pass it the mutex. So what this does is in its constructor calls mtx.lock, and internally it has something like standard mutex reference, like that. So it's holding that reference. Anyway, since it does that in the constructor, you can imagine when it calls, what do I say? Something like standard, I might put the namespace in there. I'm just going to say lock guard destructor, right? It's going to have something like mtx unlock. And maybe it's mmtx, whatever they named it in there. It's basically going to unlock when it destructs. So that means here's the start of the scope, here's the end of the scope. LG is going to go out of scope right here, and it's going to call mutex unlock and its destructor when it goes out of scope. Now, I don't like this usually because we're constructing a new object and destructing it every single iteration. So if you're in a tight loop like this, it's actually slow. I mean, you have to be in a pretty tight loop. It lasts for a long time for it to be slow enough to matter, but it is slower. So if I'm doing something simple like this, I would usually just type it like this, right? Do it like the oldest way in the book. It's like almost C-style approach. There's actually a mutex you can lock that just is a function call. And you have like a handle to the mutex or whatever, or some kind of just object. Anyway, there's also unique lock. Call that UL. I should probably leave that one in there too. Lock guard, LG, MTX, just in case someone wants to look at it later. Okay, this is basically going to do the same thing, but it's possible to share these locks and wait for multiple conditions and stuff. Unique lock and shared locks have more things you can do with them. Typically, if I'm going to use something like this, it's going to be a lock guard, and it's going to be something where I have a lot of conditions where I might need to stop locking the mutex and bail out with an error or something early. So if there's a lot of places where I might forget to unlock it, I'll do one of these, you know. Otherwise, I'll manually lock it if it's just something like a really simple case. Let's run it again just to show it still works. Okay. You can see it's still working just fine. I'll do the same thing with the lock guard. Okay. Cool. Yep. So, anyway, having each thread wait on a mutex when you're sharing some kind of data that you need to read from or write to is the way to go. But the better approach, like I said, is if you have some kind of large array of something, like say I have, I don't know, standard vector of like some elements, right? V. What I might do is I might say take v.size, you know, and I'm going to divide it by number of threads, right? And I say something like size t, what elements per thread equals this, you know, and then you'd have something like let's see, the final thread, right, is going to have to be this plus that right there, plus the remainder. So say you have like 11 items, so 11 elements, and you have 10 threads. In that case, each thread gets 1, except last would get 2, right? So you have 1 times 10 threads, plus 1 extra for 1 thread. So you can break up the word like the work like that, and each thread gets some subset of these elements. That's kind of what I was trying to like emulate here, where each thread is like doing part of the counting I need to do. Well, each one needs to count from 0 to 100,000, and it needs to add 2 each iteration. So you can imagine like 0 through 100,000 is some elements I have to work with, and this is just some arbitrary work that I'm doing. So that's the better way to do it, because if you break things up into subsets of an array you can work with, then you don't have to lock a mutex, because they're never going to touch the same data. Something else to keep in mind, though, is that if the data that you're reading from and writing to is too close to each other, the CPU puts stuff into cache, and let's say like the cache is like 32 bytes or something. I don't know what it actually is going to be, but there's a cache in the CPU that it works with. And if it's already done a, let's put in here, because I don't know if it's 32 bytes. It's different for each processor, too, and there's different levels of cache, L1, L2, L3, whatever. Anyway, if the let's see, the memory you read as part of like a structure, for example, like, I don't know, you have a structure you're working with, and there's like item A, there's like item B, dot dot dot. You can imagine, like, maybe you say one thread's only going to work with these two, and the other thread's only going to work with two more down here. You might think that you're being clever and you're doing all the work in parallel, but maybe these two items are close enough together in memory that they both sit together in the same cache, and they're both protected by the same, like, I don't know, memory fence inside the CPU, and then it causes it to be really slow because it has to wait on the second thread, even though you didn't think that you would be waiting. There is another video I watched on YouTube. It's explained this way better than I did, so if I can find that video again, I might link it in the description, because I think it's a great resource. But I didn't want to get super in-depth and talk about how to optimize everything. I'm just like, okay, here's how you can make your UI not freeze with the thread. Here's how you can make sure that if you're doing multiple threads working with the same data, that it's not going to have a race condition and cause issues like I showed you. And I think this did a decent job of that. If I went a little too fast or I didn't explain something well enough, please let me know in the comments. And in general, I mean, if you have anything to say, I'd love seeing some feedback. If it's critical, I mean, I can improve from it. And if it's, I don't know, encomiums, great. It's motivating. And it's definitely good to see that what I'm doing actually is being, what do I say, leveraged in a positive way by somebody. If I know it's helping somebody, that's definitely a rewarding thing. Anyway, I'll do the YouTuber thing and say like, comment, and subscribe. And I will catch you later. Have a nice day.